Alright, CNT120, we are looking at Chapter 3 on addressing on networks. Again, we'll break this up in multiple pieces. So this first piece, we're going to look at just kind of a super quick overview, and then more specifically, MAC addresses. Alrighty, let's dig right in here. First thing they do, and actually I'm doing this in a podcast for you, is try to break the chapter into 4 pieces. These are the major types of addressing we deal with on networks. At the data link layer, the MAC address. At the network layer, the IP address. At the transport layer, port numbers, and at the application layer, domain names, fully qualified domain names. So we are going to kind of work our way through from layer 2 up to layer 7, the different types of addressing we deal with in networks. Alright, the first thing they do with this is they give us a super quick overview of all 4 and then dig into details. So let's do a quick overview of all 4. At our data link layer, we have a MAC address. This is the address that's burnt into our network card, our NIC, meaning it is hard-coded in there. It is a 48-bit long address. So if I wrote it in binary, it'd be 48 binary bits. But typically it is written as a hexadecimal number. 12 hex digits or 6 hex numbers. And it would look something like so. So as you see, there's actually 12 numerals here, but it is actually 6 hexadecimal numbers. This right here is 1 hexadecimal number. This is hexadecimal number, and so forth. This is used to find a node on a LAN. So 2 computers on a LAN connected to the same switch, they're going to find each other using MAC address. So it's inside of a LAN, inside of a network. You're also going to find this name or MAC address referred to by all of these, depending on the author, depending on the conversation, depending on who's writing the blog or the web page or whatever. You'll see it written as physical address. You'll, because it's burnt into the NIC. You'll see it written as adapter address because it's on the network card, burned into the network card, the NIC. You hear it referred to as layer 2 address because that's in the OSI model, that's where it resides. You also hear it called the data link layer address because that's layer 2. And typically we're dealing with Ethernet networks, Ethernet NICs, so a lot of times you'll hear people say Ethernet address. All of those mean the same thing, this MAC address, media access control address. So there's super quickly as your MAC address. As I move up to network layer, we have the IP address. The IP address is assigned to every node, every interface, so every node that's connected to a network. This address can be used to find any computer, so to speak, in the world, if it is actually a public address on the internet, which we'll talk about public and private addresses later. This is typically used for routing purposes. Routers typically use these addresses to move traffic through networks. So these addresses, yes, they're assigned to nodes, but routers are going to read these to move things around. You notice with the MAC address, I did not say that. And these are also called, again, depending on the author, depending on the book, depending on the article you read, you'll hear IP addresses also referred to as logical address, meaning these are addresses that I can change on a computer. Software address, because again, this is an address I can change on a computer. Layer 3 address, because that's the layer 3 of the OSI model, which is also called your network layer. Okay, so IP addresses also get called all of these names as well. Again, we will come back later and talk more details on these. There's 2 types, IP4 and IP6, and the IP4 address is your 32-bit address. If you wrote it out all in ones and zeros, it'd be 32 bits, but it's typically written as a decimal number, decimal dot, decimal dot, decimal dot, okay, 4 decimal numbers like so. 92.106.50.200. That is typically how you're going to see an IP version 4 address. Meanwhile, there's also IP version 6 addresses that are becoming more widely adopted and becoming more used, if you will. This is a 128-bit address, which again, if I wrote it all in binary ones and zeros, it'd be 128 bits long. And it's written as 8 blocks of hexadecimal numbers. This right here, this would be a full IP version 6 address. And there's my 8 blocks of hexadecimal numbers. Okay, that's your IP version 6 address. Again, we will come back to that later and talk details. Now, I'm also going to do a quick reminder. Don't forget, I also have, along with this chapter, I have podcasts on binary and hexadecimal number systems. You are going to want to review that material because you need to know the basics of each of these, the basics, and be able to convert numbers, binary to decimal, decimal to binary, hexadecimal to decimal, and so forth. You'll need to be able to do those because as we work with MAC and IP version 6 addresses, we work in binary and we work in hexadecimal. So reminder, don't forget to do that. The next address that we run into as our transport layer are port number. Port numbers are used at the transport layer to find an application that's running. Your computer and things like servers often have multiple applications running. So to find the correct application running on a computer or server, it is identified by port number. Super quick example. On your computer, you might have your browser running, you might have a video stream running, you might have a file download happening all at the same time, email running, that sort of thing. That data coming into your computer needs to find the correct application, so that chunk of data gets to that right application. Well, that's done using port numbers. So it allows data coming in to find the right application and connect it, if you will, connect it to it. Port numbers, layer 4 transport layer port numbers. Last but not least, application layer fully qualified domain names or domain names. Every host is assigned an actual name. This would be, a name that we can read and recognize, and typically it's a fully qualified domain name. Example would be dlbrown.hack.edu. And super quickly, they remind you there's a couple parts to this. The last two parts are the domain name itself, hack.edu. Meanwhile, the first part is the actual host name, dlbrown. So you notice I kind of crossed out which was not it. So the fully qualified domain name would be dlbrown.hack.edu. Domain name is hack.edu, and the actual host name is dlbrown. That's how we identify names for us humans, so we can identify things a little bit easier. They also mentioned there's some organizations out there that their job is to maintain port numbers, domain names, and IP addresses kind of for the globe, for the internet. And the main group responsible is IANA, Internet Assigned Numbers Authority. And there's also a department of IANA called ICANN, Internet Corporation for Assigned Names and Numbers, that also works with this too. So as you start working with domain names, port numbers, that sort of thing, you start running into these organizations because they need to maintain lists of all this to know who's using what where, so there's no duplicates. That way there is no two websites out there called DougBrownNetworking.com, because that would be very confusing. All right, that's the group that maintains all that. Alrighty, I'm going to come back on the next podcast and start digging in specifically to each of these pieces.